Hi, welcome to our video on very short answer questions on wave optics. And remember one point here, some questions may be asked for 1 mark, 3 mark or 5 marks or 10 marks. So in that case, you are advised to answer based on the requirement. So state Huygens principle. Every point on wave front is itself the source of spherical wavelet which is spread out in the forward direction at the speed of light. The sum of these spherical wavelets form a wavefront. Wavefront is there. Each point on the wavefront will act as a secondary source, and the combination of these waves, this will form again wavefront. Next one is, what is interference? So when light waves are superimposed, the modification in the distribution of intensity in the region of superposition is called interference. So interference means whenever two waves are superimposed, their intensity will get modified. That's nothing but the interference. So interference generally we can observe in colors observed on soap bubble, an oil film formed on water. Then what are the conditions for interference? Basically, light should be of same wavelength. That's nothing but monochromatic. Then separation between the source and screen will be large. Then two light sources emit a light waves should be coherent. Then separation between the two light sources will be small. Then write superposition principle. When two or more waves travel simultaneously in a medium, the resultant displacement at any point is due to algebraic sum of the displacements due to individual waves. Say for example, this is amplitude is A and this is A. Now A plus A, it is giving 2A amplitude. It is a constructive interference. When two waves are in out of phase, then the superimposition will be difference of these two. Then next one is the difference between interference and diffraction. Superposition of a two source different wave fronts originating from a two coherent sources, and in diffraction it is due to the superposition of secondary wavelets originating from a different parts of the same wavefront. So it is here it is a same wavefront, here it is a different wavefronts. Then interference bands are of equal width. When come to the diffraction bands decreases in their width as order increases. All the bright fringes are of same intensity. The bright fringes are of varying intensity. So intensity will vary for diffraction, and for interference it is constant. All the dark fringes have zero intensity. In interference, the intensity of dark fringes not zero. Then so distinguish between Fraunhofer and Fresnel diffraction. For diffraction to occur, the light source and screens are at infinite distance from the obstacle. But diffraction to occur, the light source and screen are at finite distance from the obstacle. To study diffraction, lenses are necessary. So in order to focus the light, we use the lenses. Here lenses are not required. Study of diffraction is easy. Study of the diffraction is complicated. Diffraction can be studied in any direction of propagation of the light. So diffraction can be studied only in the direction of propagation of the light. In this case, the incident wavefronts are plane. So here plane wavefronts, and in this case incident wavefronts are either spherical or cylinder. Then what is the difference between unpolarized and polarized light? So whenever unpolarized light is there, the vibrations of the electric vector will be in all directions. This is unpolarized light. Polarized light we will show like. Then what is a double refraction? This is one of the important question and is the part of our Nichols prism also. So this double refraction has another name that's called birefringence. So whenever light rays passes through a material that has a two different refract indices for wave polarized in different directions, whenever the unpolarized light pass through this calcite crystal, it will split into two parts, extraordinary ray and ordinary ray. All the best. These are the most of the questions we can expect. Signing off, this is Dr. Sivanagi Reddy. Thank you.